Greeting everyone, my name is YIWEI Huang, and I'm gonna give a brief presentation on my ECTE451 project, which is Green Traffic Engineering. Firstly, I would like to thank my supervisor, Professor Quan Yu. Without his help, I cannot achieve what I have now. In this presentation, I will first give a brief introduction about my project, including basic background information and why I'm doing this. Following is the current state, which indicates currently what people have achieved. Next, I will tell you more about my project. It's about what I am going to do, what is my goal, and how would I do this. After that, I will tell you the achievement I got in this semester. And finally, comes out the conclusion. Okay, let's move to the first part. As we all know, Internet now has become a so powerful tool in our daily lives. With Internet, especially on mobile devices, there is nothing you cannot do. You can watch a video online, you can make an online call everywhere, even Google a destination at a place you have never been with. Besides, more and more services have been developed now. For example, the popular online broadcast. With all this development, more devices in network is needed to fit the requirements. Why? Because based on Cisco's report, the volume of traffic on Internet will increase with a rate of 23% annually, and it will be doubled 3 years later from now. Under such a rapid growth of traffic, we need more network devices, such as routers or servers, to handle the enormous traffic requirements. But at the same time, not the devices needed. There are other problems. The Internet consumes significant amount of energy every year. Reports show that nearly 10% of worldwide energy is consumed by networks. If there are more network devices needed, this number will no doubt go larger. Considering energy consumption is closely related to greenhouse gas emission, this would have a negative impacts on both economy and environment. So now, a new technology called green traffic engineering has been proposed. Green traffic engineering, just like its name, is a technology that aims to add green component to networks to reduce the energy consumed in network and keep the quality of service remain the same. Currently, many researches have been carried out towards energy efficiency in networks, and typically they could be classified into two layers, which are device layer and network layer. For device layer, researchers focus on individual devices, and the general ideas are developing novel routers or switches that can compute the traffic through them and then judge the status of network. The novel devices are capable of working under multiple modes with different energy consumed. These devices will adjust their mode, fitting the requirement of traffic to ensure minimal amount of energy consumed. For network layer, things are a little complicated, but one of the common ideas is to add sleeping mode to network devices. There will be an algorithm or protocol monitoring the whole network and the traffic volumes, and it is capable of moving traffic from low utilized devices to higher utilized devices within their capacity. That is, say, if there is fewer data going through a link or a router. Then the link or router will be seen as low utilized, and they will not handle any traffic after the optimization. After doing all this, the low utilized devices will be turned off to ensure less energy used. And in my project, I'm gonna find a solution that can achieve energy saving based on the same strategies of network layer. The solution is designed to gather network information such as traffic demands, and then based on this information optimize the networks, including moving traffic and rerouting the network. Finally, after doing all this, it will change the state of devices, and this will lead to the consequence that the energy consumption is reduced. Here is an example of what I have achieved. With MATLAB library, MetaGraph, and YINS algorithm, I can get a random network with uncertain traffic demands, just like network shown below. The network is randomly connected with random traffic from source nodes to destination nodes, and also these nodes are randomly selected. Based on this network, the algorithm will find and locate the links that can be switched off and give a new network topology. Let's come back to these specific networks. There are 19 links in the original network, but after the optimization, there are 6 links that can be switched off. This is just a small networks, and in a larger scale networks, I have done a lot of results, and I have done a lot of simulations, and the results show that up to 40% of links could be turned off, which is to say 40% of energy could be saved, which is really means something. Finally, in this project, I have done researches in green traffic engineering area, and with the help of my supervisor, I have worked out a solution that found minimum number of links working in the networks. There may still be some aspects that need to be improved, but the direction of my project is really helpful and right, I think, since it is related to energy saving, reduce greenhouse gas emission. In ECTE451, more components will be added in my project, such as periodically checking network demands, and develop the corresponding network topology, which will all contribute to a better performance of this algorithm. That is all for ECTE451 project presentation. Thanks for listening.